the velocity of an enzyme, meaning like how many products it can crank out in a second or a minute, a certain period of time, is going to be dependent on the substrate concentration. Where you have more substrate, we're going to be able to generate more product per second. We're saying, okay, here's a certain substrate concentration here, and here's a certain velocity there. And if we increase the substrate concentration here, I'm going to higher velocity there. And what you should see is that this kind of plateaus. Okay, why does this plateau? And I would just know this general thing. Enzyme plus substrate makes enzyme substrate complex. So it has to sit together. I always thought of it as I'm gonna bore you to death with this analogy, but it's the car salesperson and it's the person trying to buy the car. They're just wandering around the used car lot. Here's them actually interacting, and the enzyme and the substrate are together, the salesperson and the person trying to buy the car together, and we're trying to close a deal here. And this takes time, this takes effort. And then eventually, maybe, hopefully, the car salesperson can go back to trying to find another customer, and we now have a product. So a car has been sold. What we'll notice, though, again, is that this kind of plateaus, and why. Well, if we think of these are employees, and these are the customers right here, if you have 3 employees, and I don't know how many do we have here, a low substrate concentration, 1, 2, 3, 4, 5. A lot of customers don't want to be bothered, and a lot of employees are lazy. So it might just be that some employees aren't trying to sell cars. So our velocity is going to be kind of on the lower end here. We're not going to sell that many cars. And it's because a lot of our employees just aren't interacting with anybody. But what happens if I have way more customers on the used car lot? Well, there's a higher likelihood that the employees, the enzymes, are going to be engaged with the customer, trying to make a sale and close the deal. And so, now we're going to have a little bit more product being made, cars being sold. Okay, what if we just have a ridiculous amount more customers than we've ever seen on a used car lot? In fact, you know what? We have too many customers. We have so many customers that, look, every single one of our employees is engaged with the customer. We couldn't do better, right? This is the best we could possibly do. We might say that we're saturated here, right? If you double the amount of customers, well, you're not going to sell more cars, because to sell a car, you need to go through the employee, right? It takes time to make the sale and do the paperwork, etc. So you would probably need more employees, or faster, better employees, which we'll get to if you want to increase the velocity. But we call this the Vmax, the most cars you could possibly sell in an hour, the most protein you could make in a second or a minute or whatever. I would know the Michaelis Menten curve. So this is, we could go into more detail on this, but let's not. Velocity, this is how many proteins you make, how much product you're making per second. This is equal to the maximum product you could possibly make given the amount of enzymes you have, times the substrate concentration, whatever it is, over Km. And the Michaelis Menten constant, we'll talk more about this, but I would just know, if this is my Vmax, this is 1/2 of Vmax, and it corresponds with the 1/2. So the 1/2, it is the concentration of substrate. In other words, the amount of customers you need on your car lot to reach half of the maximum amount of sales you could ever hope to make. So it's the substrate needed to get to 1/2 Vmax. All right, bunch of different ways to think about Km. I would think of it as the infinity that an enzyme has for a substrate. If you have a really low Km, then that means that the protein is really, really magnetic, high gravitational attraction for the substrate. High Km means it's a lower affinity. Like we just said, maybe the second one, it's the concentration of the substrate when we're at half of the maximum velocity. And this third one, this one's really mostly just useful for when you're thinking of uncompetitive inhibitors. So we'll come back to this, but this is it is quite literally the stability of the enzyme substrate complex. I know that one's kind of weird, so put that in the back of your head. We'll come back to that. And for our dumb metaphor, we're going to think about is how enthusiastic and hardworking is our salesperson. Like how eager are they to find a customer and try to make a sale, right? Now, no, that's way different than saying they're actually good at making a sale, right? They might be eager, but just terrible salesperson, right? So let's disentangle those two concepts. Vmax. So we said that this is the maximum amount of product that our proteins can make in a given second or a given time period. And it's dependent on K2 and the total amount of enzymes, total amount of workers you have present. So Vmax is equal to K2 times the total enzyme concentration. And then if we think of our car example, let's say that the most cars we could sell in an hour is 10. Well, that's going to be dependent on how many employees do we have, how many enzymes do we have, the total amount. And K2 is like, how good of a salesperson are they, right? And how quickly can they do the paperwork and whatnot. So K2 is like how competent they are. And then, and then that kind of makes sense. Like if they're really good at doing paperwork and making a sale, and you have tons of employees, then you'll have a really large Vmax. And like we just said, we can think of it as the amount of cars that we could sell, the maximum amount, right? V is just the literal amount depending on how many customers, how much substrate we have at any given time. All right, you get it. We're talking about cars. All right, so a low Km is a can-do attitude. So it's a high affinity for a customer. It's a salesperson who's going to hustle their ass off. So even if there's few customers on the car lot, it doesn't really matter. They're meeting with them and they're trying to make a sale. So someone wants help and they're like, yes, boom, I'm here, I'm eager, let's do it. High Km, the salesperson can't be bothered. They hate their job, they hate their life, they don't want to help. So someone says, can I get help? It's just one person. And it's like, what, it's just one person. I'm on break. I don't want to interact with you. Like, I have better things to do. However, if there's like 1 million people all saying, hey, I need help, there's just, there's 30 people and not that many salespeople. The salespeople are like, ugh, fine. There's just so much demand, even though I don't want to. Now I'll help you, right? Because like you're in my face. I tried hiding in the coffee room. I tried hiding in the bathroom, but the customers are relentless. They found me and they're forcing me to help them try to buy a car. That is different than K2, also known as KCAT. This is about charisma, right? It's nothing to do with laziness or hustle. This is once you have a customer in front of you. In other words, once you're in the enzyme substrate complex, how good are you at generating a product, right? In other words, how quickly and how able are you to close the deal? So a low K2 employee just, lacks a certain, finesse where, someone says, hey, is there any wiggle room on the price? And then they say something stupid, right? So they're not going to close this deal, or it's going to take them a long time to close this deal, right? On the other hand, high K2, very charismatic. They're going to say something smooth that's going to make the the deal go more quickly. I think you get what I'm saying. All right, so again, I'm going to really hammer this in. KM and K2, let's not over anthropomorphize it, right? There might be a correlation between a hardworking employee and a charismatic one, but we're pretending like they're completely different things, right? You could have a high KM, high K2, low KM, low K2, high KM, low K2, or low KM, high K2, right? You could have any four of those combinations. And the best employee is going to have a low KM. They're a good hustle. They really want to engage with the customer. And they also have a high K2. They have a high charisma. And again, Vmax is the number of employees we have and how charismatic they are. So it does not rely on KM at all, as we'll see. So let's go ahead and look and see, if we look at different, K2s and KMs, how does this affect, like, how many cars we're going to sell? All right, this is our reference dealership. And notice that, so in every one of these, we have 10, 10, 10, 10, 10. We always have 10 salespeople. I'm not changing the number of salespeople in these examples. So that's not really a factor. Really what's changing is just how many customers we have on our car lot. We have 2 and 20 and 50 and 100 and 500. And so why have I highlighted this yellow here? The idea is when you have 500 customers versus 100 customers, you're only selling 10 cars. So you know what? Whether we're here or whether here, this is our Vmax. This is the most cars that we're going to sell, right? If you have 10,000 customers, you're not going to sell more cars because you only have a certain number of employees, and they can only interact with one customer at a time, right? What's our Vmax? It's 10. What's our KM? Well, remember, KM is the value. So if this is 10, well then 5 cars sold in an hour is going to be half of our Vmax, and that's going to correlate with that number there. And we actually know this number, right? 5 cars sold correlates with 20 customers. So these are the two values. Vmax is 10, Km is 20. All right, so now we have charisma is the same, K2 is the same, but they're really lazy employees. They do not want to be bothered. They just don't. They're hiding from customers. They're just trying to get through the day with doing as little work as possible. Now, once they're interacting with the customer, they may or may not be good, right? But we're just saying they're lazy. So again, there we go, fun. 10 cars sold, that is our Vmax. That's the same, right? But let's go ahead and see where's the 5 cars sold. It's right here with 50 customers. So now what's our KM? It's 50. So we have kind of a lower affinity, a lower willingness to bind with customers, to bind the enzyme, to bind with the substrate. And then the opposite of this is that, again, fun, we're gonna have 10 cars sold, but we've got the eager, like, the last one was Squidward and this one is SpongeBob, is they're dying to meet a customer and try to close the sale. They live for this. And we're looking for 5 cars sold, which, would be in between this and this. And so, we're going to say that it's like 10-ish. So notice in those 3 values, we had the KM was 20 for the reference, and the KM was 50 when it was the lazy employee, and the KM is like 10-ish when it's the very enthusiastic employee, right? So again, low KM means high affinity. You're very quickly going to ramp up and get to your highest possible, sales point, your highest Vmax, right? Doesn't mean your Vmax will be high. It just means you're going to get there really quickly. I mean, imagine a car that can like accelerate to, maybe the max speed is 100 meters or 100 miles per hour, right? You can accelerate to that really quickly. That is going to be a low KM. If you accelerate to that very slowly, that's going to be a high KM, right? It doesn't mean that the max speed is 150 or 50, it's 100 no matter what. Oh gosh, what am I talking about here? Okay, so yeah, what if we had more employees or what if we had better employees? I think in this example, we're mostly going to be talking about better employees. But notice that it's really the same if you're talking about K2 or E total. Increasing either one of these would increase the amount of cars that you're going to be selling, your Vmax. But we're mostly going to be talking about better employees, more charismatic. So we're going to be looking at a bad salesperson versus a good salesperson. Again, we are not talking about how willing they are to meet a customer, just how good are they at closing a deal and how quickly can they close a deal. So again, fun, we have our 10 cars sold. And so what is our Vmax? It is 10. What is our KM? Well, 5 is going to be half of that, and that's 20. Again, this is the same as it was before, 10 and 20. So here you can think of this as less employers, or maybe let's just think less charismatic. So equal number of employees, but all of them are less charismatic. So they're just going to waffle, and they're just going to blow the deal when it comes their way. And so now we're seeing that the most cars you could sell is 6. Our Vmax is 6. And that's because we have these bad salespeople, or it takes a long time to close the deal. But notice they're just as willing to meet a customer as earlier, right? They're not more or less willing, it's the exact same. And so what we see is our half of 6 is 3. So we actually have the exact same KM as before. It's just our Vmax has gone down. And what if the opposite happens? So now we have more employees or just more charismatic employees. Again, we have 20 cars sold, and half of that is going to be 10 cars, and that's going to be associated with 20 customers. Again, the KM has not changed, right? It's just the Vmax that changed. And so Vmax would be 20 and KM is 20. So as we mentioned, a good employee is a high K2 and a low KM. So I think this is just the best way to think about K2, Vmax, KM. I know it's silly and I'm certainly beating a dead horse, but I just think it's a really useful concept and it certainly could come up on your NBME, especially with how it relates to inhibitors. So like if you have a good understanding of KM and K2 and whatnot, it makes it a little bit easier to understand inhibitors. So competitive inhibitors, we have our active site right here, normally where our substrate goes, but if the inhibitor looks like the substrate, it could easily fit into that spot. So that it's going to mimic the substrate, and it binds to the unbound enzyme, right? This is the employee before they've met with the customer and tried to make the sale, right? They're just walking around on their own. That is the only time that this imposter substrate can get in. It can't get in for the enzyme substrate complex. Non-competitive, it doesn't matter. The inhibitor can bind somewhere else other than the active site, an allosteric site. It binds anywhere else. And it doesn't matter if the substrate's bound or not bound. That has no bearing. So it can bind to the unbound enzyme or the enzyme substrate complex, so when it is bound. Now, uncompetitive here, when it cannot bind in this situation, which seems weird, right? Because you're like, wait a second, it's an allosteric site. Why would it not be able to go there? Well, when the substrate gets into the active site, a lot of times this induces a conformational change for the protein. And if you actually look very carefully, this does not quite match this little curve here. But here what we've done, instead of this right there, we now have a little curve here. Why did that curve show up? Because this binding induced a conformational change, which made this curve happen. So it is only in the correct conformational shape for the inhibitor to bind after the substrate is bound. So in other words, long story short, the uncompetitive inhibitor can only bind to the enzyme substrate complex because the shape of the protein is a little bit different in the enzyme versus the enzyme substrate. Competitive inhibitor, if we're just, I'm gonna keep going with this silly metaphor, but you can imagine that like a rival car dealership sends over like actors. And okay, why would that help like hurt our business? Well, if I have a car lot and maybe there's like 8 people walking around who I want to sell cars to, if like 3 of them are actors, imposters, and their only job is to waste my time, they talk with my employees for like 3 hours. They pretend like they're going to go buy a car, but they have no intention of buying a car. That's going to waste my employees' time, and it's going to affect our bottom line, right? We're going to have our velocity is going to be lower. On average, we're going to be selling less cars per day. But if you think about that though, the Vmax should stay the same, because we said like an average day, right? When I have like 8 customers and 3 of them are imposters. But what if I had 10,000 customers on my used car lot and 3 of them are imposter actors? Well, I only have like 14 employees. I have 10,000 people in my car lot, 3 of them being competitive inhibitors, imposters. It's just the likelihood of everybody's trying to get the attention of the employee. It's just a really, really low likelihood that they even interact with the imposters. So if you have a high enough substrate concentration, enough people wanting to buy cars, you probably just won't even interact with the competitive inhibitors, and so they will have no effect. So you can kind of drown it out. But the idea though is it does take more people to get to that Vmax. And if it takes more people to get to that Vmax when you have these imposters, then it also takes more people to get to your Km, which means your Km has increased. So Km is increased, but Vmax is the same. And these are all just pictures of, here's folic acid, but you can notice methotrexate, leucovorin, things like aminopterin all have very similar shapes. And so these are classic competitive inhibitors. So you should just be able to eyeball 2 things and be like, they kind of look similar. It's probably a competitive inhibitor. Non-competitive, so for lack of imagination, this is like you just have a murderer, right? Okay, the rival car dealership just sends over an assassin to murder your employees. It doesn't matter if the employee is interacting with the customer or not interacting with the customer, right? Whether in the unbound E or bound enzyme substrate ES complex, they're just going to murder people. And you know what? If you're murdering my employees, that is less employees, my Vmax is going to go down. All right, this one's weird, but imagine that they're assassinating the employees, but the other employees aren't finding out, right? It's probably bad for morale if you know people are getting murdered, but we do not know people are getting murdered. And so if we're losing our employees here, but the other ones don't know about it, the Km is going to be the exact same, right? The other employees are just going to go to work, do the exact same job. The Km does not change. That is kind of weird, but the Km stays the same because I'm murdering one employee, but I'm not affecting the other employee. The unaffected employee's Km is the same. And uncompetitive. So here, our last example is imagine that we have the salesperson here and the employee here. They're interacting, trying to close a deal, trying to convert a substrate into product. But now the uncompetitive inhibitor can bind. And this is a different picture than earlier, but it's the same concept. The substrate binds, changes the shape of the enzyme, and only now can the uncompetitive inhibitor come in and bind. It locks the substrate and the enzyme together. It ties them together with a rope, effectively, so that they cannot dissociate. And you know what? It's kind of difficult to close a deal if you're tied together with the customer. That's going to make it a little bit weird. So your Vmax is going to go down. You can also just think of it as like you're taking an employee out of commission. They can't do their job. So if you look, Vmax is equal to K2 times the total concentration of enzyme. We have less enzymes, and therefore we are going to have a lower Vmax. What's weird though, and remember we had so many different definitions of Km, is that your Km actually goes up, right? Because Km really represents the stability of the enzyme substrate complex. And in other words, how easy is it for them to dissociate? And if they're tied together with rope, it's very difficult for them to dissociate. So a high Km actually means that it's very stable because they can't dissociate because the uncompetitive inhibitor is locking them or tying them into place. So the Michaelis Menten formula, if we do a bit of algebra voodoo, we flip everything, etc. This can be my y. This can be my slope m. This is kind of hard to see, but we can think of this as times 1 over s. This is 1 over s. 1 over s is our x, and then 1 over Vmax is our y-intercept b. So this is the Lineweaver Burke equation, and it's just a nice way to quantify things like a little bit more objectively. So if we look at this is our y, so this is the y-axis, it's 1 over v. Km over Vmax is our slope, so that is our slope. Rise over run, change in y over change in x. And then 1 over s is our x, and so that is our x-intercept. Our x-intercept is 1 over s. And then 1 over Vmax is where our line crosses the y-axis, the y-intercept. Now, this one is important to know too. It's kind of weird. The x-intercept is actually negative 1 over km. Why is that? Well, I don't feel like writing it out, but if we're saying that, okay, the x-intercept is where y is 0, if I made this 0 and I set it to km over Vmax times, let's just call this x plus 1 over Vmax. So again, we just made 1 over v 0 because that's where the x-intercept is. And instead of writing 1 over s, I just wrote x because that's what it is. If you solve for x, it will be equal to negative 1 over km. Just take my word for it. So let's combine all of this. So competitive inhibitor only goes for the enzyme. Km is going to go up because you need more people on your car lot to get the half of the maximum sales, right? Because you got to deal with those imposters wasting people's times. But the Vmax is the same because you could drown out, flood out the imposters. If you just have 10,000 million, billion, trillion customers on your lot, it's just really unlikely that the employee is just statistically, they're unlikely to interact with the imposter. The assassin does not discriminate. Enzyme substrate. It's going to go for both of them equally. Km is going to be the same because like the employees that aren't being murdered, they're going to have the exact same. Willingness to engage with employees, but your Vmax is going down because you have less employees because they're being murdered. Here, we're only binding together the employee and the substrate together with rope. We're not going for unbound enzymes. And Km, this should actually say, oh gosh. So earlier when I said, if I said it goes up, I misspoke. Km is going to go down, but down nevertheless means that you're going to have Km should go down. That's a typo. Km goes down. Vmax also goes down. They both go down. But nevertheless, it still means that you're more stable when we say that the Km goes down. So sorry about that. So here the Km is going to go down and the Vmax is going to go down as well because you know what you're also taking. It's kind of like murdering an employee if you tie them up. We have one less employee to do their job. So let's look at all of these. Competitive inhibitor, the Km is going to go up, the Vmax is going to go down. So if we imagine like this is negative 1 over 1, so this is negative 1 right here. If the Km is going to go up, instead of negative 1 over 1, I'm going to have something like, now it's going to be like negative 1 over 2, a higher number. Negative 1/2 would be, like right there. And the Vmax is going to go right there. And so we're going to get something like that. So I was close, but it's going to be like right there. Yeah? And the slope would go up as well, right? Because it's Km over Vmax. Km goes up and the Vmax stays the same. And so that would be higher slope. Non-competitive inhibitor, the Km stays the same. Okay, so that's easy. The x-intercept is the same. But the Vmax goes down. Okay, well, let's imagine that this is 1 over 1. Great. Well, if that's 1 over 1, the Vmax goes down. What's 1 over 0.5? It's something like 2. So it would be like up there. So we need something that goes there to there, and we get something, dingus, it's close. It goes up there, right? And again, we should have a higher slope because the slope is Km over Vmax. The denominator is getting smaller. That's a higher slope. All right, uncompetitive inhibitor, tying them together. Km goes down. So again, I misspoke earlier. Km goes down. That means it's more stable. They're locked together. So this is -1 over 1. That's -1. Now the Km goes down. This is going to be -1 over, like, I don't know, 0.5 is going to be -2. It's going to be like over there. And the Vmax is going to go down. If this was 1 over 1, but now it's like 1 over 0.5, that's going to go there. And you know what? Let's think about the slope. The slope is Km over Vmax. If they both go down, and it's actually important to know that they both go down an equal amount, my slope should stay the same. And actually, I was close. I'm never going to get this. But nevertheless, so the easiest way to see this is that the slope stays the same. And but all of these, like the slope, in my opinion, is an afterthought. If you know where the x-intercept and the y-intercept should be, you should be able to figure out automatically what the slope is just by connecting the dots. Okay,